Alright, I am ready to finalize this project. 66% of it has been successful. This is the hardest part. The lid is the biggest item. It's definitely completely unmeasurable on the y-axis, so I had to eyeball it. I'm okay with it. This is just purely cosmetic. Now, this is one of those situations, if you've heard expressions sweating bullets, this would be it. This is doubly challenging, or maybe triply challenging, for a few reasons. First of all, my stops here are not infinitely long, so basically that means that I cannot raise this part a lot. I mean, I can raise it all I want, but then I lose the trackability, the tracking, I should say, on the stoppers. And I don't want to lose that, so I raised this a little bit by putting 2 pieces of scrap aluminum that I have. So it's a little bit raised, but not a lot. Why is that bad? Well, if you don't do things right, pretty nasty things can happen. Like, for example, you can go into the table, and once you mess up the table, it will stay messed up. This is not like a human being where with a coagulant on his blood. I mean, once you make a hole on the table will have a hole forever. As of today, November 16, 2014, the only holes on these tables are the ones that came out of the factory, and you would need a microscope, a pretty powerful microscope to see them. This table is in pretty good shape, so I really don't want to mess it up. I have looked at my code and looked, and the way that I'm going to run this is putting a lot of pressure on my sphincter and having that button on the pause or the stop, so that if I see something going out of hand, I'm just gonna stop this super duper quick. Now, I could tell you that I have so much confidence that I will make no mistake, but I will be lying. The truth is, I have made so many mistakes before. It is pretty much insanely ridiculous to expect that it's gonna be impossible for me to make mistakes. Needless to say, I'm human, so anybody can make mistakes, but today I don't want to make one. So let's see what happens. This could be one of those videos where at the end you're glad you were recording, although you're really not glad because something really nasty happened. Hopefully that's not this kind of video. I am going to use my center drill to make the to center the holes. Then I'm going to use the pilot, then I'm going to tap, and then we're going to do a contour operation, and all very close to this table. First step a success. Now, remembering my previous mistakes, one thing that you don't wanna do here is forget to zero the tool, because otherwise it is going to go right into the part, and the part is so close to the table. That's not where I want it. This is my 964 drill bit for a 832 screw. Taking it down on C to zero it. This is my zero. Missing this step can definitely ruin the table. Don't want to make that mistake. Anyway, very close to the reset. Tapping head, don't want to mess this for so many reasons. Once, I don't want to mess the table, nor what I want to mess a $400 tool. Make this zero. Now this is fun to watch. Tapping is always an amazing treat. Hopefully not a bloody one. I I am feeling pretty good about this. I would have messed up by now, so apparently I checked this pretty good. Now there is still one step, and this would be the deadliest. I'm gonna use a mill to do a carving here. So again, just remain watchful and press that reset if you see anything going out of whack. Well, my friends, I am pleased that I didn't mess up the table, but I'm actually quite disappointed on an horrendous bug that I didn't catch in time, unfortunately. There is a blip here. I'm not certain if you can see it. I'll try to take a close-up. This is what is called the normal retract. Basically, when you're doing a 2D contour, you want the blade to start somewhere farther away from where the contour line, right? Which is all of this is the contour line, which is defined by the G code. So instead of just starting there because of vibration, you want to start somewhere far away, so the vibration dies out, and then you get your actual contour. For some reason, the software took the retract on this side of the cavity, which is odd because all of this is nothing. There is nothing here on my part on the model. So why would it not taken the start of the contour here? I'm gonna have to look into that, but that's definitely something that I'm gonna have to make sure that I look for. You know, I've made a lot of contours, and to make this bug really pisses me off because I don't think it has ever happened to me. So clearly I did something which I didn't notice, and it messed up the part. If this was something that would eventually go into production, this is a bug that you could fix. You would say, oh, look at that, here's what I did wrong. This is our experiment. The production part will not have this problem. But this is the only one I'm making. This is why this pisses me off even more, because now the only part that I made has this freaking horrendous notching here. Is it the end of the work? No, it will work perfectly fine. But man, I mean, this was looking so pretty, and this is the only freaking bug in the entire production. You know, in a way, to only have one dinky little bug is excellent. But man, I almost had such a perfect track record. I could have done this perfectly. To make matters worse, this is the face of the project. So this is what people are gonna see. So completely annoying. There was supposed to be some features in here. I'm not gonna cut them because unfortunately the biggest problem is, I mean, I can cut these two, but then I won't be able to flip the part 90 degrees. I won't be able to find the actual center. So the other two it's most likely gonna look off. It's gonna be very hard to find the center, considering that I just got rid of the center. I mean, I'm certain there are ways in which it could be done, but you know what? It is Sunday at 5:49 p.m. I haven't spent much time with my family this weekend because I have been working with this project, and this is gonna work. This was supposed to be done by Friday, and it took me 2 days. I did take the Saturday off, but this is just too much. I mean, I really have to continue, move on, just close this one. It's gonna work perfectly fine. So let me put it together and show you what the hell this is. You know, I said that it was already too late and I wasn't gonna do the cavities in here, and but you know, it's already Sunday at 6 p.m. and I also said that I was gonna show you how this looks. Well, I started putting it together, and man, I was looking at that box and it looks so 1950s. I mean, it looks like something that Flash Gordon would use. I was like, man, what the heck is this? This is the 21st century. I cannot walk into the office with that piece of crap. I mean, it's gonna work, but I also want to look at that. So I also want it to look pretty, appealing. So I started thinking, wait a moment, I don't need the whole table here. I mean, all I need is a portion of it, and then I just do it 4 times. So it's gonna be a little bit more painful, but if I find the right coordinates, all I have to do is push it against some stops and just press go. Yes, I'll have to twitch, to tighten these nuts. But basically, what I decided to do is that I'm going to use the center in X and the edge on Y. So I don't need to use the center on Y and the center on X. I mean, I can use any coordinate system that I want. So if I find the edge on X and I find the edge on Y, that's my coordinate system, and that's basically what I did. I programmed the G code to take my edge on Y and my center on X. So let's find those coordinates and run this job. Well, I didn't want to bore you with details on how to zero because we've done that already. Basically, just use the edge finder here and here, divide by 2, blam, you find the center. And then in here you find the edge, that's 0.1. So what's going to happen is, even if I'm slightly off, it doesn't matter, because what I'm going to do is that I'm going to rotate the part, and because I have these stops in here, basically the hole is going to land on the same place. It may not be perfectly centered, but man, I mean, most likely they're going to have to use some kind of quality control contraption, and I don't think anybody's going to go with that. So I think it's going to look perfectly fine. The other thing is that, man, basically this edge is almost very close to the point where I run out of Y. So this has been a very challenging part. It has exercised the limits on the Y-axis, so that is very interesting. This just makes stuff more entertaining, right? Because now we have to get creative on how to get something done with basically within the limits of the tools that we have. Like I said before, even if you have a super duper big machine, there will always be one part where you're gonna have to do this kind of going through hoops to get it done. I am ready to roll, so let's just get this puppy finished so that I can start resting. So that I can start enjoying whatever is left of my weekend, which is really not a lot. This is the weekend end. Okay, that's one. I'm gonna do the other 3 off camera. Although I'm gonna be recording in case something horrendous happens, it can be documented. But most likely the next thing will be this puppy just assembled. Well, my YouTuber friends, mission accomplished. It only took me 2 full days of machining. Designing, camming, machining, to get this puppy fully assembled. It is Sunday at 7:16. I started on Friday at around 7 7 or 8 a.m. at the latest. It was fairly early. It was a full Friday, full Sunday to get this guy. So, but it's complete. 3 parts basically. There is one inside to attach the motor, and then these 2 guys. So yes, it takes a little while to get stuff like this done. Mostly because this is not, it's not a straightforward. You have to create your models, then you have to select your processes. There were some hiccups on the threading of some of these parts. Actually, it made me waste like 2 hours there. That is documented on my blog at www.cncdude.com. And but I'm happy. There was only one glitch here, which is fairly visible, so extremely pissed about that. But hey, what can I do? Learning lessons, right? I mean, now I know that I have to be more cautious when doing to the contour. It had never happened before though. That's very weird, because usually the software is pretty good, and in fact in doing these holes, these cavities, I didn't have to worry about it. Just started on the right spot and then created the actual line that I was hoping for. So I am very confused as to how that happened. But we have this looks way better than without this hole, so I'm very happy that how that came out. And then in the back, the motor is mounted here, and we have another cavity. So we have airflow, which is basically what the customer requested, and we have a safe enclosure. It's pretty much very hard for somebody to have an accident with the blade, but then again, anybody could say, oh, let me see it. You're at your own at that point in time, right? So I think I'm pleased with the output, and definitely only possible to get something like this, an extremely good finish with a CNC milling machine. I really don't think you would have been able to obtain something like this, and with all of these features and all this stuff by hand. I mean, I'm certain it can be a approach, but to get it with such perfection, hard to believe that you can do it with a manual milling machine. But hey, if you can do it, be my guest. This being the whole project, most likely this took like 2 or 3 parts, so my apology for making it so long, but I thank you for tuning into my YouTube channel, so I'll see you on the next time.